Welcome. In this video, we'd like to show you how to generate a layout from a project you've created and calculated in emaPlant Designer, while reducing transport efforts. You will also find additional videos on the following topics. What results can you expect from emaPlant Designer? What data is relevant for the digital model of the factory? How is the digital model created? How can data be customized in the user interface? How extensive and detailed are the results? And how can transport equipment be planned? In this video, we will show you how to create a layout using the example of a gearbox assembly. First, we open the project. Then, either a calculation is performed or one of the previously calculated results is opened. The result that is now open can then be sent to EMA Work Designer by clicking on the EMA logo in the upper right corner. In the following data transfer window, you can choose whether to transfer material flow and layout data or to generate a value stream for a specific item or its product family. You can also do both. Afterwards, EMA Work Designer generates all workplaces and warehouses with the calculated transport aids and creates the value stream. Once the data transfer is complete, the objects are visible in the 3D window at the bottom and in the object tree at the top of the window. The first time the data is imported, the workstations and warehouses are initially arranged alphabetically in a grid based on the largest workplace dimensions. Each workplace and warehouse is created as a structure node, below which various objects are located, the workplace itself, possibly with a 3D object if a geometry type was assigned in emaPlant Designer, its base and workplace area, the label, calculated buffer areas, and sources and sinks for material flows, which are represented as arrows between the workplaces and warehouses. The thicker the arrow, the higher the number of transports between the workstations or storage locations. Red arrows indicate a particularly high transport effort, while green arrows represent a low transport effort. The transport effort is determined not only by the frequency of transport but also by the distances between the workplaces. Above each workstation is a cylinder that indicates the workstation's utilization. In this example, we will assume a brownfield planning scenario, meaning there is already an existing layout in which the workplaces are to be arranged. This existing layout can be imported here in various file formats, such as a screenshot or a 2D drawing file. The corresponding file can be selected using the Add Objects from File button. Depending on the file type, the selected file can be inserted with its structure or as a single object. The inserted file can then be further edited. Here, for example, the floor plan is colored black and aligned in the layout window. Afterwards, all workplaces and warehouses are arranged based on the floor plan of the brownfield factory to reflect the existing layout. Each individual object can be edited or repositioned, such as workplace labels or storage areas in front of workstations for placing raw materials or empty containers for finished parts. Repositioning the workplaces and their material flow sources and sinks automatically adjusts the material flow arrows as well. This means that the new distances between workplaces are recorded in real time, and their impact on transportation efforts is immediately visible. Once all workplaces and warehouses have been moved to their desired locations, a path map can be added. To do this, switch from layout mode to path map mode and draw the paths. As a result, material flows are no longer calculated as the straight line distance between workplaces and warehouses, but instead use the nearest path. Paths colored red are more heavily trafficked than yellow or green paths. All transport aids at workplaces or in warehouses are arranged side by side on the floor during the initial transfer to the layout. If these are to be placed on a rack can be inserted from the Work Designer library. A wide variety of 3D objects are available here, which can also be customized as needed. For example, with racks, you can adjust the color and dimensions and define different compartments for transport aids until they meet your specific needs. The customized object is then loaded into the project and moved to the correct position. It can then be copied to create a series of racks. These can, of course, also be found at the top in the object tree. Using Easy Layout mode, the transport aids are then sorted into the racks. Next, paths to the racks in the incoming goods warehouse will be added, followed by the installation of racks in the interim storage area and outgoing goods warehouse. As a result, all large load carriers in the incoming goods warehouse, the interim storage and outgoing goods warehouse have now been arranged on racks to enable space-saving storage. Of course, racks or other 3D objects can also be added at the workplaces to enable detailed planning of the workplaces and their floor space. Once the mapping of the existing layout is complete, the current transport effort is set as a reference for the subsequent optimization of the layout in the Layout data window. To reduce transportation efforts within the factory shown, the first step is to focus on the transportation route with the highest effort. This is represented by a red material flow arrow. In this example, the highest transportation effort occurs between the interim storage area and workstation 4. By simply moving, for example, the interim storage area closer to Station 4, the impact of this layout change on the total transportation effort can be immediately identified. In this case, the transportation effort is reduced by 21.8%. In this way, the transportation effort within the factory could be further reduced by making additional adjustments to the layout. These optimized transport efforts ultimately have a positive impact on the number and utilization of the required transport equipment, such as forklifts, in the factory. You can see how to calculate this using the Plant Designer based on the existing layout in the next video entitled, How Can Transport Equipment Be Planned? Thank you for your attention.